Okay, this is 4.1, Algebra 2 Concepts B. Here's our notes. 4.1 is all about polynomials, and this first thing I want to talk about is what a polynomial is. A polynomial is a monomial or a sum of monomials. Monomials. Okay. What does that mean? If we have just the letter x, that's a polynomial. Okay. Or x plus 1, that's a binomial. Okay. If we had x squared plus 3x, that's a polynomial. If we had x to the 5th plus, or let's say 6x to the 5th plus 3x squared plus 2, that's a polynomial. Okay, so these are what polynomials look like. All right. Down here we have standard form. Standard form means the degrees go in order. The degrees go in order from highest to lowest. So if we had the function, let's just say, I don't know, 3x to the 4th plus 7x to the 10th minus 3x plus 2x squared. Let's just say that. We have this function. We don't write this in standard form. Well, our highest degree, or whatever we have, whatever's attached to the highest degree, which is 7x to the 10th, because this 10 is the highest number, highest exponent, that's what's going to go first. So our standard form for that function would be 7x to the 10th, followed by our next highest, which is, looks like 4, so plus 3x to the 4th, followed by our next highest, which is, looks like this 2x squared, followed by our last, which is negative 3x. This is standard form. The next definition is the degree. The degree of that function, is the highest degree, which is 10. So the degree of that function would be 10. And the leading coefficient is whatever the first number is, 7. Okay, so standard form, we write from the highest degree down. The degree of that function is the highest degree we have. And the leading coefficient is the number out in front of the entire function. Okay, so let's look at this one. Decide whether the function is a polynomial function. That's the first thing. Are these polynomials? If so, write it in standard form and state its degree and leading coefficient. Okay, so is this a polynomial? Yes or no? Yes, because we just have 2x plus 4x squared minus 3. There's nothing out of the ordinary there, so yes. It is a polynomial. Now, let's write it in standard form. We want to make sure we do that. Okay, so our highest degree, looks like we have a 2 here, so 4x squared plus 2x minus 3. The reason the 2x goes before the 3, we can pretend there's a 1 right here, right? 2x to the first power. And 3, there's no x attached to it, so we're just going to put that last. So 4x squared plus 2x minus 3. What's the degree? The degree is right there, the highest degree. So the degree of this function is, write it in blue here, 2. And the leading coefficient is the number out front. So 4. 4 is the leading coefficient. How about that next one? 5x squared plus 2x to the third minus 6x to the fourth plus 1. Let's write this in standard form first. Let's do that. Highest degree is at 4. So we have negative 6x to the 4th plus 5x squared plus 2x to the... Oh! See, I almost messed up. What's next highest? Not 2, but 3. So 2x to the 3rd is going to go next. So after that, 5x squared. And then lastly, plus 1. Is this a polynomial? For sure. Yes, it is. Degree. What's the degree? The highest degree there is a 4. So the degree is 4. And the leading coefficient is negative 6. Negative 6. The negative goes with it. Okay, this next one. We have 2x squared plus 2x to the negative 4th plus 5x minus 4. Is this a polynomial? Whenever we have a negative exponent, negative 4, we automatically don't have a polynomial. No, this is not a polynomial. We don't want to work with it. After that, just leave it. We don't have to go any further than that. This one, 3x to the 3rd plus 2x squared minus 3 over x plus 4. Is this a polynomial? That 3 over x, that's really saying it's this right here. Is really saying that's 3x to the negative 1. Whenever we have a negative exponent, it's like we have a fraction. So, negative exponent or a fraction with an x involved? No, not a polynomial. Next on the notes. Evaluate the function for the given value of x. All we do is take our function here, and we're just going to plug 3 in for x. Okay. So, f of x, or f of 3, is equal to 3 times 3 squared minus 2 times 3 plus 1. And now we just do order of operations, where we have our exponent, 3 squared, which is 9, so we have 3 times 9 minus 2 times 3 plus 1. Okay, I'm going to do a couple of steps in one here. F of 3 equals, what's 3 times 9? 27 minus 2 times 3, which is 6, plus 1. Okay, and finally, when we solve this, we have f of 3 equals 27 minus 6 is 21, plus 1, 22. Okay, that's all it is. Okay, next one. Same exact thing. We're just going to plug 4 into each x value. And this is a semicolon here. It's a semicolon. All right. So when h of 4 is equal to 2 times 4 to the 3rd minus 3 times 4 squared plus 2. So when x is 4, we get 2 times 4 to the 3rd. That is not 4 times 3. That is 4 times 4 times 4. And 4 times 4 is 16. And 16 times 4 is, grab your calculator if you don't know it, 64. Minus 3 times 4 squared, well, 4 squared is 16, plus 2. And then h of 4 is equal to 2 times 64, that's 128, 3 times 16 is 48 plus 2. Okay, and then finally, simplifying, 128 minus 48. Let's see, we got 20, 40, so we'd be at 88 minus 8, so 80. Yep, 80 plus 2 is 82. All right, last slide here. A lot of these polynomials, well, every polynomial can be graphed. And it's very, very, very important to understand how that graph acts. So, this first one. If we have an odd degree, what are odd degrees? Well, if we have like 2x to the third, that's an odd degree. 3 is odd. That's our odd degree. Plus x squared plus x minus 1, whatever it may be. Okay, there's our odd degree. And our leading coefficient, what's our leading coefficient? It's this number up front. If we have an odd degree and the leading coefficient is positive, we're going to have something that starts at the bottom left. We have a couple key points here, and then we're going to go up to the right. That's a positive graph when we have an odd degree. Let's say we had a negative 2x to the third minus 5, whatever. Okay, this is where we're going to start in the top left and work our way down. Okay. What these are saying right here, what I'm circling. I'll start with this one right here. This is saying as x approaches negative infinity, so as x goes this way, where does f of x, or our line, go? It goes to negative. And on this one, as x goes to positive infinity, f of x goes to positive infinity. This one over here. As x goes to negative infinity, where is my line going? It's going to positive infinity. Over here, as x is going to infinity, where is f of x going? Well, it's going down, so it's going to negative infinity. Next we have these even degree polynomials, where we have, 2x squared. Well, we have 2x squared, we're going to start top and go down, right? We worked with quadratics before. We start from the top to come down to a key point, and then we go back up. If we have a degree of 4, okay, we're still going to come down. We have this little here, and then we're going to go up. We have a negative, let's say 3x to the 6th. That's an even degree. So we're going to start top and go up, right? Even degree, goes in the same direction. But since it's negative, it's going to be flipped. We're going to start down here, we're going to work our way up and come back down. Okay? So, looking here, as x approaches negative infinity, where does our line go? It goes to infinity. As x goes to positive infinity, where does f of x go? It goes to infinity. As x goes to negative infinity here, where does our line go? It goes to negative infinity. And as x approaches infinity, where does our line go? Negative infinity. Okay, let's try to work on these. Describe the end behavior, just by looking at the graph. Okay, well, you should first notice what's our degree. This was written in standard form, which it is. This is in standard form. What's our degree? it's odd. Okay, that's where we either have this one, or we have this one. Let's look. Is this a positive 2 or a negative? It's a positive. It's a positive 2. So we're going to be working with a positive graph, right? We're going to be working with this one here. And as x approaches negative infinity, okay, so we have our graph here. Sorry. Let's say we have our graph. Okay. X is going to negative infinity. We have our line in green. Where is our line going? It's going to negative infinity. So we're going to say f of x is going to negative infinity. As x approaches infinity, this way, where's our line going? F of x is approaching infinity. Okay, done. Last one. What kind of leading coefficient do we have? Or what kind of degree do we have? We have an even degree. Okay, well that's where, here's our graph, we're going to have this type of thing. And we start on the top, and we end on the top, okay? What's our, do we have a positive or negative 4? Negative, so we're not going to have this line. Okay, that's actually going to be flipped. We're going to have this right here. So, let's just take it one piece at a time. As x approaches negative infinity, so we're going negative infinity, f of x is going to approach what? Where's our line going when it's going that way? It's going to negative infinity. What about when we're going to positive infinity, or as x approaches positive infinity? F of x is going to approach going down, so negative infinity. Okay, that's it. That's all I have for you today.